Hello everybody, this is Game Scott, and welcome back to yet another Tier List Tuesday. Not only is it the first Tuesday of May, not only is it Cinco de Mayo, but it is also Taco Tuesday. Taco Tuesday falling on a Cinco de Mayo, what could be better? And you bet we getting tacos for dinner, of course. But anyway, that's not what this is about. This is about Tier List Tuesday, and this is arguably going to be the worst Tier List Tuesday. If you can't tell by the title of the video, I'm going to be ranking the math classes I took in college. What audience is this video going to reach? That they're going to care about this at the very least? Who knows? But this is what I'm doing. There's not really too many, so it should be a rather quicker. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15. 15 or so. And again, I made these clearly, and I didn't know how they would cut them off. So it's like this, but I know what they are. Except Discrete 1 and Discrete 2. I'm just going to imagine the second one is Discrete 2. And that's what we're going to go with. And I was like, you know what? I don't want to try to fix this because I don't know what they're going to cut off. So anyway, let's just get right into it. Let's go from start to finish. So the first class I took in college, unfortunately, was pre-calculus. I had taken AP Calc in high school, but the placement test that I took for math, unfortunately, was a little bit garbage, I suppose, because I didn't take the AP Calc test, like the AP test, to actually get the college credit for Calc 1. So I would have to take Calc 1 again regardless. But still, I was kind of disappointed that I had to take pre-calc. But pre-calc, it's a solid course. We'll just put it in the B category because math. I did that in high school, 11th grade, and so to take that in a college setting is like But the actual content of pre-calc is solid stuff. It gets you ready for calculus. There's a lot of lead up and build up to it, and a lot of important stuff you got there. And it's just kind of the culmination of all your other math classes that you've taken in a high school, but pushed to like the maximum level. A lot of application stuff, a lot of different types of problems, so you can't just be like, it's not like a lot of your earlier math courses in high school where it's like, hey, here's a process, repeat the same process for like 15 problems and get your answer. Pre-calc is a lot of, here's a type of problem, here's the problem we're working on, but there's like 8 different ways to do it depending on the specific components of the problem itself. So you got to have a lot of problem solving skills for pre-calc, and really all these upper level math classes, all these college classes. There's definitely an element of problem solving to it. But pre-calc, you really got to start working your brain to figure out, how exactly do I approach this problem? But as far as a college math class goes, it's just a solid B. Nothing special about it because I took it in high school. Calculus 1. Go there next. Calc 1. Let's go, baby. Calc 1 is maybe my favorite math. Because it's limits, derivatives, and integrals. And those are so good. Derivatives especially are just my favorite. And it's been so long, teaching high school. It's been so long since I've done calculus. I can remember the derivative rules like chain rule, product rule, the exponent, the basic derivatives for like just polynomials. That's the easiest stuff in the world. But I can recall slightly the chain rule and stuff. Integrals are just anti-derivatives. And of course, limits to start everything off, because what a derivative is essentially a limit. The definition of a derivative is based off of a limit. You're finding the slope of some function at any certain point Obviously, linear equations have a constant slope. There's a constant rate of change. But let's say you got a parabola, quadratic, the slope is constantly changing forever. So how you find the slope of a curve is let's say you make a secant line. You take 2 points on that curve, you find the slope of that secant line, and then you just narrow down the closeness of the 2 points. So like if you have, let's say you got just basic x squared, a parabola, you find the slope of a line where from 1, 1 to like 3, 9, and that's a somewhat close approximation. But how to get closer, let's say you check out the points 1, 1 and 2, 4. You're going to get a closer approximation for the slope at 1, 1. But let's say you move it to 1, 1 to 1.5, whatever that is. What's that going to be? 1 point something, 1.5? I don't know. I'm not doing that in my head right now. 2.25. There you go, I did it. 15 squared, but move the decimal to the left 2 times. And so the closer you move your points together, the better approximation your slope is going to be. And that's what limits are. As the points get closer and closer to 0, so that the distance between those 2 points is 0, that's going to be the derivative. And that's the difference quotient, all that fun stuff. But yeah, I remember in Calc 1 in both high school and college, they start you off with the difference quotient, be like, this is how you find a derivative. So x squared, you got to plug in f of x minus h minus f of x all over h. It's the limit as h approaches 0 and all that stuff. And then later on after that, they're like, oh, you can just bring the exponent down and subtract it by 1. Derivative x squared is 2x, dummy. And then you're like, why do I have to do all this different quotient stuff? Just tell me that the definition of a derivative is a limit, and then let me move on. Give me the power rule. The power rule for derivatives is my favorite thing in the world. But derivatives are super cool. Integrals, which are anti-derivatives, essentially are also super cool. Find the area under a curve, which is a neat little thing. All right. And as much as I like Calc 1, Calc 2, we'll put it in the C tier, not D tier. There's going to be no F tier because math is fantastic. But Calc 2 is all integrals, the entire thing. And this is where kind of what I mentioned before, you got a type of problem, you're dealing with an integral, but then there's 7 billion different ways to solve it. Like what if you're taking the integral of a trig function? Or what if you're taking the integral of, some weird thing? You have 7,000 different ways you have to approach a problem depending on the circumstances of what exactly you're looking at. In Calc 2, it was just too much. There were too many different integrals, too many different things. And I was like, get me out of here, dude. This is poop. So Calc 2, it was all integrals, but way more complicated than just Calc 1. Calc 1 integrals. Because again, you're just doing integrals the whole entire semester, and that's it. But there's like 7,000 different cases. Like what happens if you're taking the integral of this type of function, or this type of function, or this type of function? You have 7 different ways you got to approach that problem. Several different methods, depending on, again, what exactly you're looking at. So I did not have a good time in Calculus 2. Calc 3, we'll put that up in the A tier. Whenever I took this course, it was kind of a professor introduced it as like Calc 3 or Calc 3D, because it's essentially calculus in the third dimension. You start off with vectors, which are pretty easy, but vectors in a 3-dimensional space, so x, y, and z, and then you just get into some other stuff. I forget, partial derivatives, I think they were called. I couldn't tell you how to do those right now. I couldn't tell you how to do most of this stuff right now because it's been so long, but I could probably tell you the names of some things. Uh, but partial derivatives I slightly recall. I don't remember those being too bad. So those were good. And Calc 3 overall, I think towards the end of the semester we got into like polar coordinates and stuff and different types of planes instead of just a Cartesian plane. And I got a little bit kind of towards the end. But for the most part, Calc 3 wasn't too shabby. And so I enjoyed it quite a bit. Definitely more than Calc 2. It was a nice, refreshing course after the nightmare that was Calculus 2. Alright, so we got the calculuses out of the way. Those are all my calculuses. I'm going to try to go a little bit in order. Because obviously these weren't in order. I didn't take Calc 3. I probably did take Calc 3 right after Calc 2, but I had some other classes as well. Next up, let's go with linear algebra, which is matrices. You know, I think linear algebra is an S tier math class. Matrices are super cool. Maybe I'm biased as well because I think the first unit test we took in linear algebra was the only math test in college I got 100% on. Maybe I got 100% on the second test as well, but I just remember the early half or the first half was like super easy, like just nothing. The first test for sure, I know I got 100%. I'm not 100% sure about the second one, but the first one was just your basic matrix, an introduction to matrices, basically like matrix addition, matrix multiplication, which, you know, at the start, matrix multiplication can be a bit confusing, but it's not really hard if you get it. And even determinants aren't that hard, and you got cofactors and minors and stuff. Using Cramer's rule wasn't even really that bad, because again, Cramer's rule is just finding determinants to solve a system of equations. So matrices, I really like what you can use matrices for. It makes a lot of things much easier than trying to do it algebraically by hand without matrices. So I just really liked linear algebra. It was a good course. I had a lot of fun with matrices. I remember the term eigenvalues and stuff, but I could not tell you exactly what they are at the moment. I'd have to go back and check. But they also had some fun words in linear algebra, as I had just mentioned, eigenvalues. So that was fun. But linear algebra, I'd say that's a pretty solid course. Again, might just be biased because I got 100% on a test in that class, and that's like never happened ever again. So linear algebra, solid course. Matrices are super cool. If you have any interest in math at all and you're in college, I'd recommend you take linear algebra even if you don't have to, because matrices are just super cool. And speaking about classes that are super cool and you should take, there was one class that's not on this list because I didn't have the prereq for it whenever it was offered. It wasn't offered like every semester, maybe every spring or something. But number theory seemed like such a cool course, and I couldn't take it because I didn't have the prereq for it, and that made me sad. Because number theory just seemed like such a cool course, you know, number theory, like numbers. And I'll get into that a little bit later. Actually, how about right now? Before that, let's do principles of programming. Principles of programming was pretty cool. That was my only computer science class. I threw it in here just because it was a requirement for the math section of my degree. Like technically it was listed under computer science, but you know, I had to do principles of programming as part of the math part of my math teaching degree. Obviously much more than the education part. Right? This was for math related reasons. But principles of programming, the course I took, we learned C++, which was pretty cool. Learned how to program code a little bit in C++. And once again, as of right now, I probably could not tell you how to code a single thing, not even how to code the program just saying, hello world. I couldn't tell you. I mean, probably maybe have the textbook somewhere. I could look through it or something real easy, and then it might start flowing back a little bit. But, programming is pretty cool. I think it's an A course. Um, you got, loops and stuff, if-then statements and while statements. Um, Loops are cool, as I mentioned. It's a cool course. Programming stuff is cool. But again, as a bunch of programmers do, debugging stuff, be like if your program has an error while executing, you're like, oh God, what's gone wrong? What do I have to fix? Because it doesn't like super tell you what's wrong. It's just like, hey, somewhere in this line maybe it's like this isn't good. No, 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 no. And I'm like, well, what do you want me to do? So debugging a program is definitely not the best thing, but principles of programming, I had C++ is what I had learned to program in, if that's the correct phrasing for that kind of statement. Principles of programming was a solid course. I enjoyed it. The professor was also an interesting dude. I loved the math department. I was so sad um, that my official department was education, because the math department, they were a lot cooler. I enjoyed my math professors and my math courses a lot more than I enjoyed uh, my education courses. And that might be typical for like all high school teachers. You know what they say, if you haven't heard this little statement about teachers, like if you want to go into like elementary school teaching, you're there for the kids. If you want to go into teaching for high school teaching, it's because you have a passion for the subject. Right? And of course, all teachers, they have a passion for kids regardless. It's not like, high school teachers don't care about their kids, they only care about the subject they're teaching. No. All teachers have a passion for their kids, but if you have a very strong passion for your kids, you're going to go into elementary teaching. But if you care more about the subject, then you're going to want to go into high school, because you got a strong passion for a particular subject. You want to teach high school. Elementary stuff, anyone could, like, quote unquote teach elementary school. I say quote unquote because the content in elementary school is, common knowledge, hopefully, for most stuff. Learn how to read, learn how to write, what is the alphabet, how to spell. Basic science stuff, basic math stuff, addition up to division probably. Maybe no, I don't think in elementary school you get into light algebra. Maybe very, very light algebra, but without calling it algebra. I don't even know. Elementary school was a long time ago. um, but yeah, if you like small children stuff, you're gonna go into elementary school teaching. But if you like one particular subject, but you still want to teach, you're gonna go into high school. Just because, elementary school teachers, at least where I was from, they taught everything. You were in that same room for the whole day, and you get a little bit of everything. So that's kind of how teachers work. If you have a strong passion for a particular subject, you're probably more likely to go into high school teaching. But if you want to go into teaching just for the kids, like, and only for the kids, you're probably going to want to go into elementary. And then if you want to go into teaching middle school, then you're just insane. All right. So those are the three types of teachers. You got a strong passion for the subject is high school. Strong passion for the kids is elementary school. And a strong case of insanity, you want to teach middle school. All right. Anyway, let's get into it. Discrete Mathematics 1. Now, I'm going to put this under the A category. For the sole reason this is the only class I failed. I really like the content. I did have to retake this, obviously, because I failed it, and it was part of my degree. But there's one math professor in the math department at the university I went to that he prided himself on the number of kids he failed. And so Discrete 1 was a prereq for number theory, and it was a prereq for a lot of math classes that I would need to take. And the only professor that was teaching it at the time I really needed to take it was that math professor who was like, oh yeah, I failed so many kids. And so, I had to take it, and of course I failed. But first of all, what discrete mathematics is it's proof. It's a really different type of math. Because you're not doing math, you're proving math. You're like, if x plus 3 equals 6, then x equals 3. Obviously, you know that, but you have to prove, why can't x equal something else, whatever. You're proving a statement. You're not solving, you're proving. And so discrete mathematics is the first math course you take where you're doing that, right? And it's just entirely different. You start off with like logic and truth tables and everything, and that's all nice and dandy. But the math professor that was extremely difficult, he had us, whenever we had homework assignments, they were due like weekly. They were like 5, 6 pages long, front and back, because he'd ask and require, not ask, he'd require that we copy down the problem, what the question stated, word for word, and again, some of these proofs were, or some of these problems even were just long paragraphs. And so he asked that we, copy down the problem, and then we do a direct proof, which is just kind of writing through the proof in paragraph form, be like, this is true because of this, and then this is true because of that, and so on and so forth. And then in addition to a direct proof, he'd have us do what is called an analysis of proof, which is something like A1 and B1 statements and then A2, B2, and it's just nonsense. And I've talked to other people that took discrete, not with that professor. And even when I took discrete 1 again with a different professor, we didn't even talk about analysis of proof. Half of the people, not even half, like 90% of the people I've talked to about discrete mathematics, I mentioned analysis of proof, and they're like, what is that? A1, B1 statements? I don't. And so it was just a whole bunch of baloney. He'd have us essentially write a proof 2 times, but in different styles. And it was nonsense. And everything had to be perfectly exact the way he wanted it. There was like no room for, a little wiggle room. It's like, hey, if this doesn't look exactly like this, then it's wrong. And you get points off. And so it was just a way tougher class than it needed to be, because whenever I retook it with a different professor, I got an A for sure, but I think like a high A even, just because it's not that really too hard of a class. The professor just made it too hard. And the first time I took it with the hard professor, we start out with, because again, it was a prereq course for a lot of stuff, so it was a very populated and filled class. We started off the semester with like 23 people or something, 24, 25, low to mid 20s. And by the end of the semester, we had like 8, because people just were like, I'm not going to pass. And as much as I need this course, it's just not worth it to try to put in the effort that I'm just not going to get a passing grade on. And so people were dropping out throughout the semester. And, maybe in hindsight I should have, but it was just garbage. I did fail, of course, so I had to retake it. But it was nonsense. But then the second time I took it, it was wonderful. Like I said, I got an A. You got truth tables, logic, that was the introduction to it. And then you get into actual proofs. One of my favorite types of proof, actually, is induction, which at the time I did not like induction. But kind of throughout the rest of my math career, kind of going through more classes, I started to really like proof by induction, which is just something to prove like an infinite sequence or something. Be like, you know, you start off assuming if k equals 1, then this is true. So using that, you have to prove that the same thing is true for a value of k plus 1. Like if it's true for k, you got to prove that it's true for the following term, k plus 1. And so at first it was like kind of difficult to kind of grasp exactly how to write the proof and what was going on. But throughout the rest of my math career, I started to really enjoy induction. It's a pretty cool type of proof. All right, before we get into discrete 2, let's talk about intro to proof. Intro to proof is really kind of discrete 1 again. I'm not sure exactly why they made the course, um, but I enjoyed it. The professor I had for this course was really cool, and again, it also was a new course. Again, I'm not sure. Intro to proof, I think discrete 1 was a prereq, but really it was just an extension of discrete 1. It was just more proofs and stuff. Maybe without the introduction of like logic and truth tables, of course. It was just like all proofs the whole semester. But it wasn't really anything super new that you didn't learn in discrete 1. It was just more of it. And it was a new course at the time I had to take it because I had done a little bit of a switcheroo for my degree. Not really changing what it was, but just changing how it was labeled and titled. But then I had to switch back because of reasons. And whenever I had to switch back, I had to take the new course requirements for that degree. And this was conceptualized and added as a course onto that degree, so I had to take this. But Intro to Proof, really, it's just kind of an extension of Discrete 1, so it's a fine class. I had a good time. Now let's go to Discrete 2. Discrete 2, this is maybe more because of the professor. The professor wasn't hard, but I don't really have like super. It was just a non-memorable math professor, which again, my math department was filled up with rock stars, and this one was just kind of it was forgettable. Not forgettable. I don't mean to sound rude, but there weren't really any super fond memories of the professor. Not that they were bad. I was just indifferent. Like it was a college course, It was just a basic generic professor, Nothing special, not tough, not hard. It was just, you're here, you exist. We're doing math. But discrete 2, you know what? I'll move it up to A. I just want to keep this balanced, but again, math is great. So it's going to be top loaded probably. But discrete 2 was pretty cool stuff actually. It wasn't super, it was still kind of proofs, but it got into graph theory, which graph theory is pretty cool. This is the only course I took that touched on graph theory, but it was really cool. And I don't mean graph theory as like in a Cartesian XY coordinate plane. Graph theory is like you got a bunch of circles with lines connecting them, and you got to be like, hey, can I go from this starting point to this end point, like without taking any lines twice and without like crossing over stuff. And graph theory was just a really different field of mathematics that I hadn't really seen before. And it was really pretty interesting. Again, it wasn't too difficult either, which was nice, of course. So Discrete 2 is a good course. Other than graph theory, I don't remember too much from it, but I think graph theory took up at least a big chunk, at least a third probably of the course. And again, a third means, it's 2/3 other stuff, but it was like, whatever. Graph theory is the big thing I remember from Discrete 2, and it was cool. Probability and statistics, let's put that up in the S tier. That's a good course. Probability and statistics, I had a pretty easy time with this. And believe it or not, I don't know, once you got into some stuff, it wasn't necessarily the easiest, but the professor I had was like really great for this course, and everything just kind of made sense and clicked as it was happening. I didn't have to kind of like, go back, look through the book and be like, what exactly did this mean? Like, as the course was happening and as we were learning stuff, I was like, that makes sense. You got to do that, so you do that. And again, the statistics side of it, especially because statistics is statistics. Probability, there's, 7 billion different scenarios you can come up with for a probability problem. But statistics, it was just kind of like, hey, do some stuff and do some stuff. Um, I don't know. They're mushed together. They kind of intertwine. Um, but it was kind of going back to just an earlier style of math where it's like, here's a process, you do the process, you solve the problem. And, 4 different types of problems, of course, but I found it rather straightforward. And I had a couple other friends in that course that were struggling a little bit. They weren't failing, but they had like maybe low B's or C's in that course. And I was like, not to be rude, but this isn't hard stuff. um, but I just found that the college course, probability and statistics, really not too bad difficulty-wise. And probability, of course, is fun. You draw a card and out of a deck of cards, what's the probability this is going to happen? Or you got like a poker hand, what's the probability you got a pair or whatever. It's a cool topic as well. It's a cool field of mathematics. So I really enjoyed probability and statistics. The professor I had for the course was super, and it was a solid course. Right. History and roots of math. This is going to be a B tier class. Because the first half of the course was super interesting. It was what it sounds like. History and roots of math. We learned the Egyptian symbols for numbers. There was a dude, a stick figure with his hands held up in like a V shape, or like a Y in YMCA. That was like a symbol for 1 million. And then there was like a fish and like a flower, and we learned these symbols for how like ancient Egyptians notated their numbers. And of course, they just had a base 10 system for the most part. They're like 1, 10, 100, 1,000. And we learned how to, add, subtract, multiply, divide with how Egyptians did it in ancient times. How, it was really cool. So the first half of the class, A or S tier. But the second half of the class might be like C tier, and it was very dry. The second half of the course, we got into Euclid's Elements, like geometry, his book of elements, and we just like proved each theorem in like his first book. You got like the parallel postulate. We were in Euclidean geometry, so we included the parallel postulate, but then using those, the initial postulates prove, I forget if this is a postulate or like one of the first theorems, but if you have 2 points, then there is exactly one line that goes through both of those points. Again, that's a very early theorem or maybe one of the initial postulates. Again, postulates, if you don't know, those are just things like you have to assume are true, otherwise, there is no geometry. So postulates are things you can't really prove because in order to prove stuff, you have to use prior information, and if your initial statement, you can't prove your initial statement because there's nothing prior. So those are postulates. They're just things we have to assume are true. Otherwise, we can't. Geometry does not exist. But then theorems that follow the postulates use the postulates to prove your theorem. And then theorem 2, it uses the postulates plus theorem 1. Theorem 3 uses the postulates plus theorem 1 and 2, and so on and so forth. You use anything prior to prove something. Right? And so yeah, the second half of the course, it was basically prove like every theorem in the first book of Euclid's Elements, which was just super dry. We went in, it was a Monday, Wednesday, Friday course, so it was 50 minutes. But you just went in, we did like a few proofs, and we left. And we're like, cool. And it was just, the second half was super dry, not interesting. And I wasn't a fan. College geometry, D tier. Again, college geometry is, proving. It was kind of a similar thing. There was a section of college geometry where we were proving a bunch of Euclid's elements, and I was just like, I already did this, and this is garbage. College geometry, again, I took it with the same professor that I did the first time I took Discrete 1, right? The super hard math professor. I did manage to pass college geometry with like whatever I needed to. I think since it was a math degree requirement, I needed to pass with a C. I just barely made it, but it was garbage. It was the professor, of course, he was the same tough professor, and I don't really like geometry. Maybe this class is why, but the first year of math teaching, I taught geometry, and high school geometry is fine. Um, but then this year, I'm teaching Algebra 2 instead of geometry, and I'm like, oh, hallelujah. I much prefer algebra and stuff like pre-calculus, algebra-based topics, rather than the field of geometry, the field of math that is geometry. But college geometry, again, it was just a bunch of proofs. You know, you have your geometry knowledge. It's not learning new stuff. It's just proving stuff you already know. And I don't care for geometry in the first place. Again, I don't know if that is a current thing or it was a current thing at the time. But coming out of it for sure, as of right now, I know I don't really care that much for geometry. So college geometry was a tough course for sure. Probably definitely made tougher once again by the professor that was teaching it. Um, and yeah. Alright, let's see. I don't know what to do. Uh-oh, I clicked a button. Nothing happened. Cool. No, let's do intro to analysis. This one is abstract algebra. Um, intro to analysis. These last two classes. Well, no. Before we do that, let's do teaching math. I had two teaching math courses. Let's just say these are solid B tier. There were two of them, but they were kind of the same. They were taught by the same professor. It was the education professor of the math department. So this was a math course taught by a math professor, but it was like the one math professor that had a very strong educational background. So this was like an education course, but in the math department. It was strictly like, how do you teach math? What are different strategies? And of course, we talked about NCTM, those 8 elements. I think it's 8 strategies and tools. Like, hey, this is what you want to do in your typical math class. You want to challenge kids, but not to the point of frustration. You want to see, I think they called it productive struggle. And there were a bunch of other, guideline strategies you kind of want to implement in your classes to have a good, productive math class. So once again, these were two different classes. They were kind of a continuation of another. I couldn't even tell you right now one real distinction between the two. It was just, hey, we want you to take 2 semesters of this course, but we can't really say take the same course 2 times. So they're like, hey, we'll make it into 2 courses and call it slightly different things. But really, I couldn't tell you the distinction of the content. We did different stuff, sure, because it was mostly the same group of people in both classes, but it was just a continuation, really. I didn't see it as anything more than that. I will be like, oh, I think there were 403 and 404, math 403 and 404. But I couldn't tell you, oh, math 403, we did this, and math 404, we did this. So I could just tell you, hey, throughout both of these courses, I'd tell you these are probably some of the things we did. But I couldn't tell you, be like, oh, I remember 403 for sure, and we did this. It was just kind of an extension of one another. But those were cool classes. It was nice to get like a strictly math educational stuff, because a lot of education classes too, like they struggled to implement math in our discussions. Like we had a content literacy class, which was like, we had a book set. Hello. We had like a book set where you had to get a bunch of books on the same topic, and of course that works in English classes, science, history, whatever. But math class, what are you going to do in math? You just garbage in education courses. Um, you got it's just hard. Math is hard. um, and the education professors in the education department too were like, hey, math, you try your best. Be like, here's a project we got to do. Everyone have a good time. Math, you're probably going to struggle a bit and die because nothing really applies to you. But try your best. Do whatever. So it was nice to have a strictly, math education course. Cool, cool, cool. Last two, these were like the highest level math courses I took: Intro to Analysis and Abstract Algebra. Intro to Analysis, let's say these are tough because these, again, were very hard classes. I think Intro to Analysis is a B tier class. What this one is, I believe, again, they were so tough I don't even remember half of the stuff, more than half of the stuff. Intro to Analysis, I believe, is proving calculus, which sounds terrifying. You take all this Discrete 1, your proof classes, and then, you took Calc 1 maybe your first or second semester, and now at the end of your college career, you're proving one of the first classes you took. That just sounds terrifying. You're proving, hey, Calc 1, you're finding, hey, this is a derivative of this. Awesome. But then Intro to Analysis, you're proving, like, why that is the derivative. And the only thing I can really remember is, like, delta epsilon proofs, which is, like, proving limits and or derivatives, which may be both. Because, again, derivative is essentially just a limit. But these were both very tough courses, and I don't remember much from them. But Intro to Analysis, at least I remember kind of the main idea of the course. I could be wrong, but I believe is, a lot of proving things from calculus. And so I'd rate that as a B tier class, even though it was very tough. It's a B tier. And finally, Abstract Algebra. I'm going to put that down to the C tier just for a little bit of balance, but also that's kind of my feelings. Abstract Algebra is, I couldn't even tell you. I remember we learned about rings. I couldn't tell you what they are, but I remember rings. I think that's about it. This is such a tough course, even though, these were more of my most recent courses that I took. These are still, 3 years ago at this point, 3 or 4 years ago. And it was a tough course for sure. And it also didn't help, I think, abstract. Towards the end of the semester, maybe like the last 3 weeks or so, the professor left on maternity leave. And then we had a new professor come in that knew what he was doing, but of course just taught it in a completely different style than what we were used to with the professor we had the rest of the semester. So we're like, okay, we're kind of on board, but not really. And it was a super tough way to finish the semester for sure as well. Again, maybe that was Intro to Analysis. I don't even remember. Because now that I'm thinking about it, I think whenever we had that sub, we were like proving integrals, and that would fall in line with what Intro to Analysis is, proving calculus stuff. But I don't know, I think it was abstract, even though, I don't know, life is hard. One of these two, we had a sub, not a sub, but another professor come in for the last 3 weeks, and it was just different than what we were used to, the teaching style for that class. All right, and that's it. That's my tier list for the math courses I took in college, plus this one computer science class, which was fun. C++, it was a good time. So, and we still managed to do a good decent video. It's a little shorter for the tier list side, but that's all right. So once again, that's it for this tier list video. Again, they come out the first Tuesday of every month. I have an idea potentially of what I want June's to be, but we'll see how that goes. So thanks for watching, everybody. Again, if anybody watched this, I'm not sure necessarily who is going to be interested in this tier list, but that's what we're doing. So thanks for watching, everybody. If you enjoyed the video, if you made it here, leave a like and a comment. If you want to see more videos similar to this one, again, like I just said, tier list the first Tuesday of each month. Subscribe as well. Once again, thanks for watching, everybody. This is Gamer Scott. I'll see you next time. Bye-bye.